What if I told you your VLANs are completely isolated right now? That's right, your finance team can't talk to marketing and HR can't reach it. But before you start rewiring everything, there's a smarter solution. In this video, I'll reveal 3 game-changing techniques for Inter-VLAN routing, including the secret router-on-a-stick method that saves ports and money. Watch now, your network is about to get way more powerful.
Each VLAN is a unique broadcast domain. Computers on separate VLAN are, by default, unable to communicate. To allow communication between VLAN, inter-VLAN routing is required. This can only be done with a Layer 3 device, such as a router, as these interfaces can be connected to separate VLAN. As a reminder, the switch is a Layer 2 device. There are 3 different ways to do inter-VLAN routing. For example, you can do this with a router that has a separate interface in each VLAN. This is called traditional inter-VLAN routing. VLAN are associated with IP subnetworks. This configuration makes routing in a multi-VLAN network easier. On this topology, the PCs of VLAN 10 must go through the router to be able to communicate with those of VLAN 20. The problem with this solution is that you have to use a router interface for each VLAN. The more VLAN, the more interfaces you have to block on the router. So this solution is not really scalable. Another solution is to use a Layer Switch 3. Some switches can perform Layer 3 functions, which replaces the router, as a 3-layer device can perform inter-VLAN routing. Traditionally, a switch is a Layer 2 device. That is, it examines the head of Layer 2 where there are MAC addresses to route packages. And the router examines Layer 3 where there are IP addresses to carry out the routing. A Layer Switch 3 combines the functionality of a switch and router in one device. It switches traffic when the sources and destinations are in the same VLAN, and routes traffic when they are in different VLAN, i.e. on different IP subnets. To activate this function on a Layer Switch 3, it must configure VLAN interfaces using the IPs of each subnet. This option is more scalable than the first option, the one of the router with a separate interface for each VLAN. In addition, a router transmits traffic through the trunk that is configured with the switch. And in fact, using a 3-layer switch avoids this bottleneck. A Layer 3 switch is primarily a Layer 2 device that has been upgraded to have routing capabilities. And a router is a Layer 3 device that can perform certain switching functions. The last option is known as router on a stick. The advantage of this solution is that here the configuration of the inter-VLAN routing does not require to block a physical interface by VLAN. It is possible to create sub-interfaces that each belong to the IP subnets of the different VLAN. This means that a single physical interface connects traffic between multiple VLANs. The router performs inter-VLAN routing using its sub-interfaces. These are multiple virtual interfaces that are associated with a single physical interface. Each VLAN must have its own virtual interface. That is, they must be configured independently with an IP address. In general, sub-interfaces are set up with subnetworks that match the name of the VLANs. For example, in this topology, the sub-interface 0.10 corresponds to VLAN 10 and 0.20 to VLAN 20. This makes it much easier to understand the network especially during troubleshooting.